Good morning. I am going to handle the subject metrology and measurements. The metrology and measurement subject, we will have an overview of the subject. The first unit is concerned with the units of measurement, and the unit 2, linear measurements, linear measurement devices such as sine bar, limit gauges, etc. And the angular measurement devices, vernier protractor, and the different angle gauges. The second unit, and in the third unit we will discuss about the CMM and laser interferometry, and in the fourth unit form measurement, thread measurement and form measurement, and in the unit 5 now we are going to study about the force measurement, temperature measurement and everything. And in the uh, and in this units, so the metrology is very much important, and it is one of the important subject, and it is not only important for mechanical engineers, it is important for all other branches. The subject is very important for all other branches. So in this unit 1 we are going to study introduction to metrology, need of metrology, elements, workpiece, instruments, persons, environment, and their effect on precision and accuracy, and errors in measurements, and types, control, and types of standard. And in this unit 1 it is very important, the precision and accuracy. The accuracy is the term used in metrology. This accuracy concerns with whether it conforms with the true value, and the precision is the repeatability of the instrument, and the instrument should give the readings at all the times. It should give the same reading at all the times. It is called precisions. Okay, and types, control, types of standards. This we are going to study in this unit 1. Then we will go for the definition of metrology. Metro means measurement, logy means science. So it is mainly concerned with science of measurement. Suppose if we are going to measure the length of a building, we have to use tapes. Length of a building or breadth of a building, we have to use standard steel tapes for measurement. And if you want to measure very small sizes, we can use steel rules and scales for measurement. But if you want to measure the distance between the earth and the moon, the distance is around 1,85,000 kilometer. And if you want to measure the radius of the earth, it is 12,500 kilometer, and the diameter is around 25,000 kilometer, and it is not possible to measure by ordinary methods, so we have to go for some modern methods. Okay, for this purpose we are employing optical devices and laser interferometric devices for the measurement of for such a critical measurements. Suppose if you want to measure the temperature inside a cupola furnace or temperature inside a boiler, which will be around more than 2000 degrees Celsius, it is not possible to measure it using the thermometers. For this we have to use some optical devices such as optical pyrometer. Nowadays some modern measurement devices are also available, like CMM. Modern measurement devices like CMM was available. CMM will automatically take readings, and it reduces the job of the quality control people. In every manufacturing industry, there was a separate department called quality control department, and this department will take care of the measurement, and it controls it for control purpose. They have to take measurements, and they have to confirm whether it conforms with the original true value, and if there is any error, it has to be corrected. So need of inspection. So suppose if we are making a bolt and nut, so the dimensions of the bolt should be very accurate to fit into the net. So the interchangeability of manufacture is very important, and the material and conform to the established standards. All the materials should conform to the established standards. It should meet the standards, and by means of measurement we can find out some problem areas, and will take some corrections, and it is said to be the critical areas in every component. Some dimensions are critical dimensions, and for example, in an automobile, the piston cylinder and piston inner dimensions, the piston outer diameter and cylinder inner diameter, both are critical dimensions, and they should be very accurate. There should not be no cylindricity, or there should not be no dimensional errors. So they can be measured using metrological devices, and to produce parts having acceptable quality levels, they should with reduced scrap and wastage. Scrap and wastage can be minimized by employing quality levels, and to purchase good quality of raw materials, tools and equipments. This measurement is very essential, and to take necessary efforts and reduce the rejection percentage also. This metrology measurement is very much essential. Then elements of metrology. So we are going to study the standard. Standard is a physical representation of unit of measurement. Always we have to compare our object or our original measurement with the standard, and if there is any deviation, it has to be corrected. So always we have to compare with a standard. There are some primary standards, secondary standards, tertiary standards are available. Workpiece. A workpiece is a thing or object. We are going to measure the dimensions on this object. Then instruments, and the instrument is with this device only we are taking measurements. Okay, this should be free from this instrument should be free from errors, and it should not get any wear and tear, and the type of environment, and the instrument must be selected based on the tolerance of the parts to be measured, the type of environment and skill level of the operators. So in the instruments should be selected based on the least count. So least count is also important in metrology. Least count is nothing but the minimum distance that can be measured by an instrument. For example, a steel rule will measure a distance of 1 mm, because it can carry 1 centimeter, and in the 1 centimeter is divided into 10 divisions. So it can measure a minimum distance of 1 mm. Similarly, the screw gauge will measure the least count. It has a least count of 0.05 mm. So similarly, every equipment, whether it is a pressure measurement devices or temperature measurement devices, they have the minimum, they have the least count. The least count of the instrument is very important, depending upon the accuracy. If more accuracy is required, and more accuracy is required, you have to go for another type of instrument. Then person, that is a measuring person is very important, because his experience and his training poses very important problem in the measurement, and he has to take accurate measurements, and proper training should be given to employees regarding the measurements. So it should not be vary from person to person. If one person uses equipment, the result will not be different, and both persons result should be same. Nowadays, in order to avoid such problems, digital displays have been employed, and directly it will be measured by strain gauges, and the strain gauge will provide resistance to the circuits, and it will be directly measured by the strain gauges. Then another one, another one factor is environment. The environment also plays an important role in the measurement. The temperature, due to temperature, that instrument get instrument get deflected. Due to this, a wrong measurement will be given, and dirt in the instrument will give a wrong reading, and humidity of the instrument, humidity of the environment will also affect the readings. And vibration, there should not be no vibrations, and these are all some environmental factors that affect that environment. If you take a reading in vernier scale n number of times, it will not give the same result at all times due to the environmental conditions. So because of the environmental conditions, the reading may change from time to time. So these environmental factors should also be taken into consideration. And accuracy and precision. Accuracy, it is an ability of an instrument to respond to a true value of measured variable under reference conditions. So it should be conformed with the true value. It should how closely the measured value agrees with the true value is accuracy. That is, this with this instrument we should be able to, with one instrument, if it is said to be accurate instrument, it should give the true value at all times. And so the difference between measured value or observed value and true value is said to be the error of measurement. Okay. And then precision. Precision, it refers to repeatability or consistency of measurement. If you take measurement for the first time, you should give the same reading. If you take measurement on the second time, you should give the same reading. Third time, n number of times, you should give the same reading. That is called precision of the instrument, or repeatability or consistency of the measurement. Okay. So see the diagram. It is of high accuracy. First diagram shows it is of high accuracy and high precision. That is high accuracy and high precision. Because this is a target, it should not be kept away from the target. So it is on the targeted level, mean level. It is on the target, so it is high accurate and high precision. High precision means, and it gives a instrument gives the same reading again and again on the target. So it is high accuracy and high precision. Here low accuracy, it is away from the target. So it is of low accuracy, but precision is high. The instrument gives the readings again and again on the same place. So it is of low accuracy, high precision. And here high accuracy, because it is on the nearer to the target. So it is of high accuracy, but precision is not good, because one time it gives a different reading, another time gives a different reading. So the readings are different. So it is of low precision. And the fourth diagram of low accuracy, it is not on the target, so readings are away, and also low precision. So low precision, it is not giving the same readings for every readings. All the 6 readings are different. So low precision. So the equipment should be highly accurate, and it should be highly precise. Factors affecting standards of measurement: coefficient of thermal expansion, elastic properties, stability with the time, calibration interval, geometry compatibility. These are all the factors affecting standard of measurement. Factors affecting workpiece to be measurement: the coefficient of thermal expansion, elastic properties, cleanliness, surface finish, surface defects such as crash, waviness, adequate datum of the workpiece, thermal equalization. The factors affecting characteristics: scale error, repeatability and readability, calibration errors, effect of friction, inadequate amplification, deformation, consistent geometries. Factors affecting person: training, skill, ability to select measuring instruments, attitude towards accuracy, planning measurement techniques. Factors affecting environment: temperature, humidity, atmosphere pressure, clean surrounding and medium, vibration, thermal expansion effects, thermal equalization effects.